All right, day 5. Today we're really going to get into why we have been reviewing slope. I know a lot of you are like, why are we doing this? We did this in Algebra 1. Let's remember what we can remember about parallel lines. Parallel lines never cross. Perpendicular lines do cross, and they form a 90-degree angle. A lot of times you see it. Here comes a line, here comes a line, and you see that little box. That's perpendicular. Now in this situation, it's asking us what is the slope of line A, what is the slope of line B, and down here at the bottom, what do we think these are? Do they look parallel? Do they look perpendicular or something else? I personally think they look parallel, but that's because they're not crossing and because they don't appear to that they're going to cross if we were to keep going. But let's check out their slopes. I'm just drawing in the rise and run here. So if we had to do the slope of line A, we would say from the left point to the right point, we would go up 2 and right 1. So the slope is 2 over 1, or 2. B appears to be doing the same thing. So they have the same slope. It would make sense to me that parallel lines do have the same slope, because once their slope becomes different from one another, they will change in terms of their steepness. Now here, do we think parallel, perpendicular? Neither. Well, I mean, I could see where they might be able to make a 90-degree angle. Let's check out their slopes real quick. Looks like line A is line A from the previous slide. But line B is totally different. Line B is someone is sliding down the hill here. I don't have 2 good points. Let's see. Yes, I do. I'm going to do this point, and I'm going to do this point. So down 1 and right 2. So down 1 and right 2. Now, these use a lot of the same numbers. That's interesting. But they have different slopes. So we think they might be perpendicular. So we can come up with some rules based on these. And if we'd had a protractor, we could have gone and measured that second one, to see if they were perpendicular. But the rules that we can come up with from those 2 examples is that when 2 lines have the same slope, but they're not exactly the same line, like lying on top of each other, then the lines are known to be parallel. Now, these words might be new to you, and I'm going to talk about them in just a moment. When the lines are negative reciprocals, that is when they are perpendicular. And you can fill these in at the top of page 17. Now, what you might want to add is that negative reciprocal looks like this, like in our previous example. If I take the 2 over 1 and the negative 1/2, negative means they have opposite sides. So I'm going to write this here, opposite sides. And all that means is One is positive, one is negative. Okay? And we have that. We have a positive one and we have a negative one. Now, reciprocal means that the fraction has been flipped. Now, if we look at the example that we have, here we have a 2 over a 1. Here we have a 1 over a 2. And this one is positive, and this one is negative. So these are considered negative reciprocals. Now, if we multiply them, another way to check is their product, meaning when we multiply, do we get -1? That's another way of telling. So let's multiply these. These aren't too hard. 2 times -1 equals -2. 1 times 2 is +2. And -2 divided by +2 is -1. So those are negative reciprocals of each other. And if that's a little confusing, don't worry. We'll hit it when we come back together and we will talk about it some more.